So thanks for joining our session, the delegates for NetApp Astra. A warm welcome. We will start with Astra, but before we do that, a little bit about ourselves. Myself, Sayan Saha, I'm a Senior Director of Product Management at NetApp for Astra. I am 8 months young at NetApp at this point of time. I joined NetApp from Amazon Web Services, and previously I was at Red Hat. So between the two companies, I have built a bunch of open source products or products based on open source projects, including ones for Kubernetes. My partner in crime today will be Garrett Muller. He runs engineering for Astra, but that's just a very short intro. Astra is actually his brainchild. He has worked for many years on ONTAP, which is NetApp's flagship storage operating system. And he also created Trident, which is NetApp's dynamic storage orchestrator, which is really well adopted in the industry today. One of the first external storage, dynamic storage orchestrator that was created. So a lot of good stuff has been done by Garrett and NetApp, and all the hard questions on Astra, like if you want to know internals, they go to Garrett. So with that, let's start off. You have moved your Kubernetes apps to you have moved your apps to Kubernetes. Either you refactored them, or you created new apps, or you just lifted and shifted. Because those are the paradigms we see with our customers. They're running, they're humming, and they're stateful. So they use persistent storage of some sort or some kind. What do you do though if you accidentally corrupt your cloud native database on Kubernetes? It's not that straightforward. How do you get back your data that is not corrupted? What do you do if your public cloud AZ or region hosting your Kubernetes cluster is having an outage? It's not obvious all the time. And how do you quickly move your applications to a separate cluster to test with more traffic? With Kubernetes, you can have lots and lots of clusters. I just heard the customer for hours yesterday who has 700 clusters running in production. How do you do blue-green testing? How do you move things around very quickly? You can do that today with 25 steps, but it's not easy. Now, you guys already know this, that Kubernetes was stateless. Enterprises drove stateful applications to Kubernetes. This is all old news, yesterday's news. We're not talking about that today. And for the most part, persistent storage for K8s, as Nigel indicated towards the beginning of this session, is a solved problem, right? The CSI interface is stable. There's plenty. There are 92 implementations of CSI drivers out there. They're doing the job, right? So consuming persistent storage for Kubernetes it's not something that is a problem that it was 3-4 years ago. Okay, when I started on this Kubernetes journey myself at Red Hat. But the next wave of stateful applications on Kubernetes actually need more than just persistent storage, and these are business critical applications. They need to be highly available. They need to be protected from disaster, and they have mobility needs. And I'm quoting a survey here from CNCF, which is publicly available, where 55% of the respondents of the CNCF survey in 2020 said that they are using stateful applications in containers in production, and a whole bunch of other people contemplating doing that. So people are moving or working, trying to move their stateful applications to Kubernetes because they like the platform. And for the most part, Kubernetes, the move to Kubernetes is also developer-led. Developers love Kubernetes, and they need state in their application to work well. So NetApp's Trident has solved the persistence problem for stateful applications from the NetApp point of view. So this was originally released in 2016. It's a CSI compliant persistent storage provider, but saying that it's CSI compliant is not doing justice, because Trident does a lot more than what your typical CSI compliant driver does. It basically gives you, very advanced features, exposes very advanced features from NetApp storage arrays like adaptive QoS that you can take advantage of in your Kubernetes applications if you are using Trident. So it's more than that. But again, Trident has been the forerunner here, establishing NetApp's credibility in this space, and is doing a great job today. However, what we have found out, and mostly through our Trident customer base perspective, that stateful applications need more than just persistent storage. Persistent storage is a great start, but that's not everything. That's not the only thing people need when they're running their business critical apps on Kubernetes. Even in the cloud native world, data cannot be lost or corrupted. That's a given. Business continuity is more important than ever, and in cloud native world, it doesn't go away, right? So you cannot have an outage for hours and everything is not fine. The other thing that there are a couple of other things that Kubernetes has added to this equation, which you may not find, or even if you find, it's not that common in the traditional world, is application portability and mobility is more important. Thanks to Kubernetes, you can run and scale your clusters easily. I mean, fundamentally, at its core, I think about Kubernetes as a cluster commoditization technology. That is, you can launch a bunch of clusters, run your apps, take them down, extend them, and Kubernetes makes it really easy. Consequence is you end up, creating lots of clusters, and sometimes when you have that many clusters, you need to move the apps that are running on them from one to another, and it's not very easy with Kubernetes today. The other thing that Kubernetes has also brought into the mix because of this, making it really easy to run clusters, is the application data that's created inside a Kubernetes cluster by apps is sometimes more valuable than the clusters themselves, because the clusters come and go. You create them, you delete them, but the data that was created by the apps in those clusters, they need to be managed beyond the life cycle of the cluster itself. And enterprises need a solution for that, especially in the FSI space, because data is, it needs to be governed and retained and all that. So there's a lots of data management needs that have cropped up. And although these needs are there, Kubernetes data management is still not very easy. So even if you look at although persistent storage is a solved problem, provisioning it and protecting application data is still complicated. Moving your applications from one Kubernetes cluster to another is tedious and error prone. There's not enough Kubernetes tooling for app aware, disaster and data recovery or backups. There's CSI standards for taking a volume snapshot and cloning from a volume, etc. But there's nothing that kind of encompasses the entire Kubernetes app, and I'll come to that. There's more on that later. And the community is doing a great job, but there's still a lack of open community standards and APIs in this area, and the community is kind of trying to fill in as fast as it can, but customers need these things today. So what are customers doing? They are actually working around. In many cases, they are only running stateless applications on Kubernetes. And so it's a powerful platform, but they're not able to take advantage of it. In other cases, they're running the stateful portions of an app in K8s, and the stateless portions of an app in K8s, and the stateful portions outside K8s so they'll run a VM. They'll run a database in a VM outside the Kubernetes cluster, and try to manage and maintain state and store state and access state from that, which works, And in other cases, what we have seen is customers are simply using some fully managed database as a service in a cloud, or object storage actually outside the Kubernetes clusters for maintaining state. Now, all these approaches, they work, but if you have a multi-hybrid cloud strategy, they sometimes run counter and can lead to a lock-in, which might be difficult for you to resolve once you have moved a whole bunch of applications and architected them that way. So we are introducing Astra. Literally, we're launching it today. We are, it's been in service for a little while, but GA, we're launching it today to kind of take care of a lot of these issues Astra is actually the world's first fully managed data management service, built for Kubernetes. And I'll go into the fully managed aspects of Astra a little bit later, and you'll be also able to see that live when Garrett gives you the demo. But it's really truly the first of its kind. The use cases that Astra is going to cater to and is catering to right now are things that we talked about. It's data protection, data disaster recovery, migration and portability, audit, retention, governance that enterprises need to run their business critical apps on Kubernetes. And how we're doing it with Astra is what is the big clincher, is that we are using NetApp's proven storage and data management portfolio, both in cloud and on premises, to make it happen. So it's really the best of NetApp, coming to Kubernetes for solving its data management issues. So with that, let's focus on what's unique. So Astra today operates on the application as a whole. What I mean by that is Kubernetes apps can have lots of things. They can have pods, deployments, stateful sets, daemon sets, config maps, secrets. They all make up an app. A standard Kubernetes app may have like 7, 8 resources, even a small app. And so if we focus just on the storage or the infrastructure aspect of Kubernetes protection, we're going to miss out on how customers actually want to look at Kubernetes, which is from an app perspective. So when we designed Astra, we made sure that this was the primary focus. We are not, we're looking at app-aware data management for all of our workflows and for all of our use cases. So it's not, okay, let's take a snapshot of a volume, that's attached to a pod and then clone it from it and move it, right? Or back it up that way. It's actually, identifying your application and operating on the entire set of resources that an application consists of as a whole. So we focus on the application as one unit and not just individual components. This is very important. And all of this, and the way we build for it, the way we construct it, and the way we go to market with it is all around this application awareness. We actually are, billing for Astras with managed apps, like how many apps you're managing per minute, as opposed to, amount of storage managed. That's not how we're doing it. And so that reflects in the design philosophy. From the design philosophy, go to market, we are app-centric. So this is the classic layer cake, to understand where Astra fits in. We're basically asking our customers, bring your app, bring your cloud, and bring your Kubernetes distro. And Astra with Trident and NetApp storage portfolio will do the rest. So we are not competing with any Kubernetes distro out there. We'll work with everybody, whether it's on-prem or in the public cloud, self-managed or fully managed. So this is very important. Just want to make sure that Astra will be working with the Kubernetes that you want to use, not mandating that you must use this Kubernetes or that Kubernetes. You choose your Kubernetes, you choose your cloud, and you choose your app. We do the rest. So what does Astra provide? So basically, if you look at it, and there's a long, we're starting with this, but this is just the beginning, So application-aware data management for protecting data with snapshots. Enable disaster or data recovery with remote backups. You can migrate apps with instant active clones. You can audit all the operations that were done to your app with activity logs. So, per user. So you can see, user 1 took a snapshot at this time, backed it up that time, cloned this application from this cluster to that cluster at that time. So all of that is available, which is very valuable sometimes for a lot of customers because of all the data and the apps that are getting created in these clusters, and they want to keep a trail of what's going on. And secondly, which I want to really kind of emphasize on is we really designed Astra with application and data portability in mind. Not just that you can use Astra to move your application from one cluster to another cluster, but across regions within a public cloud, across on-prem and public clouds across clouds with just a few clicks. And that's the clincher. We have made Astra extremely simple to use. You can do all of this today, but you need 45 steps. And there's so many use cases our customers talk about today that where this is absolutely critical. So customers often move their app and data from one region to another region in the cloud because of data residency requirements. For hybrid use cases, we see customers who want to move their applications from on-prem to the cloud because they have a lot of data on-prem, but they don't have compute to process the data. So they move it to the cloud because in cloud, you can have on-demand compute capacity to crunch that data. There are other requirements like follow the sun, like you have application teams across the world where, they need to work on an app along with the data at different times of the day. So there's so many use cases for this, and we are building Astra to make sure that we can cater to all of these scenarios, and that's the most powerful, and not just like, okay, you can do this with a bunch of command lines, and a bunch of configuration tools, but just 2 clicks, and you'll see the power of it when we do the demo. But this is something that's very unique. So what is Astra? In what form does it exist today? So today, Astra is a fully managed service, which is operated by NetApp, providing a consistent experience across clouds. So it's an always on and updated service with latest functionality. You have to download no software. You don't have to install, patch, upgrade, manage, or license, nothing. And this is the console you will see. If you are using Astra to manage GKE clusters in Google or AKS clusters in Azure or on-prem clusters, eventually, AWS clusters. So there's nothing like, for each of this cloud, everything is different. That's not. Once you add a cluster to Astra, it looks exactly the same. And some of them could be in Google, some of them could be Azure, but it's exactly the same. And the interface that's exposed to you to take a backup of an application doesn't change. So that's like really powerful, for because a lot of our customers have, multi-cloud, or I'll say hybrid cloud environments, and the last thing they want is to learn and relearn, tool sets and that are specific to a different Kubernetes system. Even though there are standards around it, there is stuff that's slightly different. And we kind of, provide you a single pane of glass for doing all of that without needing to worry. So it's very powerful, and it's UX and API. So it's both. So you can use the UX, and then the API is coming in a month, and you'll be able to use completely programmatically do your disaster recovery workflow. So it's that way very powerful. So the vision for Astra is to be a true multi-hybrid cloud data management solution for Kubernetes. We are starting on the left. So we have support for applications running on Google Kubernetes engine, running on Cloud Volume Service for GCP. CVS for GCP is a fully managed NetApp storage service. So, and we're providing that. We'll add support for Azure soon, followed by on-prem and AWS. So that's when this happens, and all of this is going to unfold literally in the next year, within next year or so. You're going to see a true multi-hybrid cloud data management platform that you can use across or within, and even if you do not have a multi-cloud use case, many customers don't, you can still use it across hybrid cloud or within a cloud, and that will just work, and it's totally up to you how you want to use it. So we'll provide all the features that you might need, and then you can use a subset.
In the case of on-premise installation, I was wondering, where is Astra software installed? Is it on cloud? Is it on premises? Is it kind of cover or umbrella?
So that's a very good question. So initially, we are going to have an on-prem variant for Astra that will look exactly like the cloud variant, but it will be self-managed on-prem. But for hybrid use cases, when you have clusters both in the cloud and on-prem, we're going to have that managed from the cloud. So the reason we are doing this both is we have 2 classes of customers. There are some customers who absolutely do not want to use a cloud connected tool. for managing their on-prem, while there are others who would love to use a cloud-connected tool because they have hybrid storage use cases. So we'll do both.
Great, thank you.
So how does Astra work? So Astra today, literally, these are the three things. It works in three simple and easy steps. The first thing that you do is you just register your Kubernetes clusters with Astra. That's the first thing you have to tell Astra that, hey, I want you to manage or watch these clusters. Once you do that, Astra will automatically discover your applications in the Kubernetes clusters. And after that, and you have the option to choose once the apps are discovered, you have to choose whether you want them Astra managed or not. Say you have 10 apps and you only want 3 of those to be managed because the others are stateless or you don't care, they're test applications, whatever. But the 3 are production and you need to take snapshots on a daily basis. You can choose those 3 and add them to Astra and ask Astra to manage them. At that point, what you get is a menu of data management operations that you can choose from. You can set up protection schedules, like snapshot schedule, backup schedules. You can view the activity log of who has been doing what. And at some point, if you do not want to have that application managed, you simply unmanage and we stop managing it for you. So basically, it's real simple. It's like 3 easy steps, and you do all of this without downloading, installing, patching, managing, upgrading any software. It's just add your clusters, and we do the rest for you, including, and which is, I didn't talk about it as much, including provisioning the storage. So all of the storage provisioning is automatically done by Astra. It actually lays down Trident on the cluster. So when you kind of choose, go through a menu of adding a cluster, you also get to choose your storage class. That's already done. And after you have chosen the storage class for your default storage class, you're off you go. And Garrett will have a demo on that, so you'll see that. So Astra in a nutshell, sorry, go ahead.
I just wanted to clarify really quick. One of the common thread that I saw, at least from the storage layer, was the NetApp storage and the cloud volumes across all the different cloud providers. Is it true that the NetApp storage is a strict requirement? And do you have, if so, do you potentially have any plans to add any other cloud native storage components to that in the future?
Yeah, thank you, Adam, for this question. Very good question. We're starting with NetApp storage, and we are picking the ones that are fully managed, at least in the cloud. But we definitely see an opportunity to add cloud native storage to Astra, because if you look at the functionality that Astra provides today, it's actually storage layer agnostic. Like, you could have any storage there, and we should be able to manage it for you. We should be able to take backups. We should be able to do snapshots. We will be able to clone. We'll be able to restore. We'll be able to do more data governance irrespective. So we're definitely looking into adding cloud native, storage offerings from the cloud providers. But it's still kind of a roadmap, whiteboard item we're discussing. So I cannot give you the exact plans today, but it's on our, it's something that we are actively looking at.
I have a follow-up question for that.
Sure.
As part of the onboarding process in our simple and easy 3 steps, if I don't already have NetApp storage backing my cluster, will this process migrate my existing applications to that NetApp backed storage, or is that something I have to do?
So at the currently, you will have to do it, but we are looking at tools, migration tooling that makes it easy to move. Say you have your apps running today on some other storage. We are looking at how to make it easy for you so that you don't have to. Right today, the onboarding process doesn't include that step, because we think that's something that has to be you have to be very conscious when you make that decision. But we'll try to make it as easy as we can. And I think it's container-based storage migration is probably much easier than VM-based storage migration because of the amount of data involved and how the volumes are carved out, etc. So to answer your question, it's not included in the steps, but we'll provide tooling to make that happen so that you can basically take advantage of Astra for your brownfield applications.
Okay, great. And that second step where it discovers my applications, that feels a little hand wavy at the moment. So are you going to get into exactly how it's doing that discovery and what components it discovers automatically?
Yeah, so I think that's something we can show that you in the demo, like how it is doing it, because we have come, we have basically with our combined, we have done a lot of research with customers on how best they, what are the most common ways by which they deploy their applications, and we have chosen the most popular methods so that we can go and discover based on how they deploy. Now, having said that, we think this will evolve as Kubernetes formalizes what actually is an application, and there's a SIG in Kubernetes working on this called SIG apps. We will adopt it, but right now, we use Helm charts, we use labels, we are adding operators, which are the most popular ways of deploying Kubernetes applications on a cluster. We are going to kind of we're going with those for now because they're kind of a de facto right now. But as the Kubernetes community comes together and defines SIG apps and defines a more formal application posture, we're going to adopt it.
Okay, great. Thank you.
I also have a quick question about storage as well.
Sure.
Because Astra is making its own decisions, or basically depending on the cloud, I think there are different kinds of storage, but NetApp storage being used, and currently it's just that. So there are different performance levels as well within NetApp storage environments. I was just wondering, how is it making those decisions based on whatever storage is using underneath? Or is it that you can choose? So if, for example, Cloud Volumes and Cloud Volumes ONTAP both are available on a certain platform, is there a decision-making process over there which is manual, or is it automatically made? And how performance metrics are sort of calculated as to how to get a certain level of.
So today, when you actually add a cluster, to Astra, you actually have to make that decision, like what is the default storage class, and we will display you the 3 performance tiers for CVS, for example. It's it's standard, premium, and extreme, I think, or ultra, I forget, one of those, and you kind of have to choose. Now that becomes your default, but if you want to deploy apps with a different storage class, you can always do that anyway. So it's something that you choose during the setup of a cluster today. But we're going to make it so that we believe that as we add support for cloud native storage, there will be a wider choice of storage classes, and you'll be able to make that decision both times. That is when you initially add a cluster, and later on when you're actually adding apps and you do not want to use the default storage class, you'll be able to use a different storage class if you need to. So Astra, in a nutshell, it's a fully managed service, the first one for managing data management, built for Kubernetes data management. We are using proven and industry-leading storage and data management functionality from NetApp. That's like a pretty big thing. 25 years of enterprise deployments, technology coming into this space, and it's a consistent and simple data protection management experience that you'll see just now.